All right, AGS1 kids, welcome back. Today we're going to quickly talk about the 1.2 growing dots task. Just to refresh on what this task is, you start with one dot in the beginning of the problem, and then after 1 minute it has grown to the second diagram. Please notice that that one dot has had 4 more dots added onto it, so this brings us to a grand total of 5. In fact, let's get a separate color and say that this first diagram has 1 dot, this one has 5, and then if you count up this one, I believe it has 9. Please notice that 4 more dots have been added on to the previous diagram. That if you just look at this inside here, that's the exact same as this diagram. And that the inside, this might be too many highlighters, of this is the same as this diagram. So it's always the previous diagram with 4 dots added on in the corners. Excuse me. So if I was to try to draw the 1, 2, 3, 4th diagram, it would look something like a center dot, then 4 on the outside, then 4 more. So it looks like the previous one, but then we would have to add 4 more fresh dots on the outside. So 1, 2, 3, 4, bringing us to a grand total of 13, I believe, if you count them up. Please notice that the inside here is the exact same as this entire diagram, but we just added on 4 more dots in the corners. So 1, 5, 9, 13. Do you guys see how these numbers are growing? That's right, they're going up by 4. So I think you can actually fill in this table kind of quickly. 1, 5, 9, 13, 17, 21, 25, if I did my math correctly. Then this question here says, how many dots will there be at 100 minutes? So I think of this kind of visually, that if you start with your dot in the center, and then you have these big diagonals full of dots, that all the dots added on, like the diagonals here, like there's a bunch of dots in here, and a bunch of dots coming off here, and a bunch of dots coming off here. I'm not actually doing 100, I'm just kind of showing that's how many they go off. There's lots of them. These would all be matching sizes, because the pattern was that every time they grow 1 more in the corner. It's just at the same rate. So I think that each of these would have 100 dots. So you get this purple butterfly, plus you got that one in the center. So I think this is going to be 401 dots. What expression would represent how many dots there are at X minutes? Well, we could sort of draw the same diagram again. So you're always starting with that center dot, and then there's a bunch of dots on the outside. But now we don't know how many dots there are. It's just X. So if you think of each of, that was awful. If you think of each of these as X dots, we have 4 of them. So an expression for that would be 4x. But then don't forget about that little guy in the center. That's always a constant. It started with this amount of 1 in the middle. So I think an expression for this would be 4x plus 1. Last question. What is an arithmetic sequence? You didn't know it, but we've actually been working with an arithmetic sequence. Well, maybe you knew it. I'm not going to talk down to you like that. You guys, the big feature of an arithmetic sequence is that it's going up or down by a constant number each time. So the jump from 1 to 5 is a plus 4 to get to here. And then there's another plus 4 to get to here. An arithmetic sequence doesn't always have to go up by 4. It can go up or down by any number, but it has to stay constant each time. This number here is known as the common difference. Whoop, that's not how you spell common, Jolly. Common difference. Yeah, or sometimes they use the lowercase d for that, but I'm not sure where this curriculum is going to head, so I'm just going to leave it at that. All right, we'll catch you next time for Mod 1.3.